IoT is, but I'll take it a little further and explain a few things related to IoT and some statistics. And then I'll go on to how IoT by itself has become a trend in this present era, particularly in the era of Industry 4.0 and the latest industrial revolution, how IoT is become or has become part of or as a trend. And next, the third topic, I'll show a few examples of research and other projects that I'm involved in at the University of Ragel, and the type of research we do, which can be tagged under this IoT label. And the last part, I'll talk about the new trends in IoT. So second topic is how IoT has become a trend, and within IoT, what are the new trends, the emerging trends, how we can take it forward, how different aspects of computer science, engineering, information technology, or information communication technology, all these come together into a particular field or the industry, and how IoT is driving ahead on this aspect. So that's the last topic I have. By the way, I noticed that you have been announced that you can ask questions towards or you can put the questions in the Q&A. So please feel free to do so. I'll try to answer those questions as we go whenever possible, without just completing the whole presentation and having the Q&A at the end. I'll try to answer questions if there are any after each subtopic. So that's the plan. So let's start with what's IoT. The term IoT has internet in it, basically Internet of Things. So as you know, internet started way back about 40 plus years ago. And when you started internet, we just wanted to connect computing devices or computers together. And who are behind these computers are people. Right, so we just wanted to have people connected through some network, and that is how. So internet, as it is it's actually Internet of People. So, but later over time, we the people started using devices other than just computers, starting from mobile phones. Over time, various other devices started coming into picture, and people started seeing the need for the usefulness or the utility of connecting these devices together. And these devices, most of the time, are going to work on their own. No person behind it operating it most of the time. So they are things. So the idea of Internet of Things is going from Internet of People, how we can put things together, and they're going to communicate with each other. And do various other activities according to what we program them to do. So that's the idea of the basic idea of what Internet of Things are. And just to elaborate on it, we can think of a lot of anything, right? So any things that are behind or connected together through internet. And why do we connect them? Is we find some utility, some usage for connecting them together. It could be a simple utility like we just want to get some information from that device. Say, for instance, we put a temperature sensor somewhere, so we can collect the temperature information, just some simple information, temperature alone. That it can start from somewhere simple like that. The thing can just be a temperature sensor that connects to the internet through some mechanism. Or it could be very versatile thing which can control, let's say, a big factory, right? So the thing can be starting from something very simple to something very complicated. So here you can see a large number of examples. And the present trend, mostly pre-Industry 4.0, is that these things are mostly consumer driven. So these things are generally related to consumer electronics, things that people use, that are the most commonly used Internet of Things in the present or the past. But future, it's changing. Future, other things are coming in. I'll talk about that during the trends in the later part of my presentation. So as of now, as you can see, most of these things that are highlighted here are related to consumers or consumer electronics in short. So just to give you a perspective, this is from McKinsey Global Institute, who does surveys and release findings. So this is sort of a prediction or an estimate. The market or the technologies that are going to disrupt the market share are listed here, the top 12. And out of the top 12, as you can see, we have the first one, which is mobile internet. And then we have automation of knowledge work. So work, what usually are done by people, can they be automated? So that's the second one. So these ones are the estimated. In fact, like these numbers are not really the revenue, but so impact of size. So they are called direct impact or potential direct impact of these particular applications, internet, mobile. So you can just basically see a comparison between these different technologies. Mobile internet, automation of knowledge work, Internet of Things is, as per McKinsey, it's the third in the list in terms of the impact, disruptive impact it has. The numbers here are in trillions of dollars. Right, so Internet of Things is somewhere on the top. In fact, the way how this classification goes, there are other aspects of these items that could also be part of Internet. Internet of Things, things like advanced robotics. There can be things that are part of Internet of Things. So these are like not very clearly defined or taken out, but however, depends on the application and the way how it is divided. So you can see Internet of Things is at the top. So what do you mean by Internet of Things? From the same publication, Internet of Things, as you mentioned, is third in the list. And the 2025 estimate or the impact estimate is about 2.7 to 6.2 trillion dollars. And at the same time, the same can drive sort of the industry with a productivity of about 36 trillion. That is what is estimated. What are under Internet of Things? Things that are networks of low-cost sensors and actuators of for certain applications, starting from the examples I gave: data collection, monitoring, decision making, and even things like process optimization or process handling and optimization. So it can start from simple sensors to more complex computing devices, so things that are connected to internet to do various things. So that's the current trend and what's happening and the estimated numbers for 2025. So in fact, these numbers were published very recently, if I'm right. So this particular one was published only this year, mid-June, May or somewhere this year. And these numbers were like a bit lower than the estimate we had pre-COVID. As you might know, during COVID or post-COVID, there are a number of things happened. One is things like inflation across the globe, like in Sri Lanka, but not at that level, inflation, and things like transportation issues or logistics issues that happen related to this, the war that is happening some other part in the Europe or closer, and then the chip shortage we have. With all that, this estimate is has come down compared to how it was a few years ago. Still, we are on a track to have higher impact on or related to Internet of Things. So just to give you a little different perspective regarding the same item, Internet of Things, and number of devices that are connected, and also an estimate. So this estimate is again from a recent estimate from another study done by IoT Analytics. So they talk about global IoT market forecast, number of billion connected devices. So these numbers are in billion. In fact, the estimate is that as we speak, by 2022, the total number of IoT devices connected across the globe is 30 billion devices. So however, the number here is not every device that is connected, but as I have highlighted here, so these are the count only on active nodes, devices or gateways that concentrate the end sensors and so on. So not every sensor and actuator are counted here. So therefore the count here are much lower, like somewhere like the present numbers are somewhere around 15 billion nodes. So these numbers are much larger compared to something like you consider computers or mobile devices. In fact, like computers are in millions and mobile phones are in billions, but not as many as the connected IoT devices, which are things that are not related to mobile phones. So mobile phone numbers are in billions, but not as high as this. So like I said, the numbers are total number is about 30 billion. But if you only consider things like gateways, one device that connects a lot of sensors, it's considered just one. And therefore the total average is about 15 billion here. And also you can see, given that these devices are supposed to connect through internet, there should be a way of connectivity. And as you can see, the recent trend, how these connectivities are going or achieved, particularly things like in the recent years, the growth rate or compound average growth rate. You can see the compound average growth rate in the recent years are increasing, particularly on devices that are connected through the new generation like communication technology, which is 5G, which was not there earlier. So that is expected to grow further and also connect devices. In addition, the second largest numbers are coming from these low power wide area network devices, which are used for long range communication for IoT devices, for IoT communication. So talking about IoT, we can't ignore the communication part or the connectivity part of it, because this is the Internet of Things. They are all connected, and therefore internet come into picture, the connectivity come into picture. So that's just to give you a perspective from where we want to do or where these things are, and based on the current connectivity or the communication technology, how the forecast of Internet of Things in the market and the number growth. So this actually, like after these numbers are up to somewhere here, it's the present numbers, and the rest are prediction for the future. Okay, actually, yeah. So you can see the actual numbers are until 2021 Q4. So 22 onwards, it's prediction. So this was published sometimes back, end of 2020, beginning of this year. So that's basically just a quick background and what IoT is, and what's the present status, and how it's a driving force or a disruptive technology in the whole global setup, and an important technology to consider. So now said that, so please feel free to those who are joined late, feel free to put your question in the chat or the question Q&A box if you have any. I'm observing that as well. If you have anything, you can, I'll answer this. Right. So now that we got a basic idea about what's Internet of Things, next we'll see how Internet of Things has become a trend now, right? So it's not about the new trends in Internet of Things, it's not, but it is about how Internet of Things is has become a trend in our day-to-day life. So I'll take some examples. I hope most of them you can relate them to yourself or others, what's happening around. So this is just to connect or relate the technology to our day-to-day life. So let me start with a few trends. So one obvious trend is the smart homes. So smart, as you know, how the home or our living spaces, office spaces becoming smarter is by having connected components or connected things. So these things, what they are going to do is they are going to enable us to understand the environment and also to make decisions about this environment based on the understanding, and then control the environment if required. Right, so that's one of the things that are on the rise, and therefore it is the smart home is one of the trends in IoT at present, where we all are experiencing it in one way or the other. So, however, the way how Internet of Things are evolving, particularly in a country like Sri Lanka, things like smart home are as of now happening as consumer electronics or devices closer to people than to the home. However, it will take lead and become part of the buildings, part of the home in the very near future. That's the prediction. And the same will happen, or same is happening or has happened in other part of the world already. So that's the first one, how internet like IoT has become a trend. There are other places where the internet of IoT is a trend. Places like, I have highlighted a few here, transportation, agriculture, insurance, telecommunication, and so on, right? So places where it's possible to do the same thing that I mentioned about homes, where we can monitor, like sense or observe the environment, observe what is happening. It can be an environmental observation or it can be a process observation. So you understand what's happening, and then you use this understanding to make decisions. You collect that information, make decisions, and then you can also apply these decisions to various situations or to control these situations as well. Another place where this IoT is becoming or has become a trend is healthcare industry. So healthcare is something that we all care a lot about, and particularly about personal care and or our care of our loved ones and so on. So as you know, even wearable devices, things like smartwatch and also health watch or various other devices related to health have become part of the Internet of Things. Not just the watch, even things like a waving machine or any other device where it can identify your day-to-day activities or your sleep patterns and various other activities that are simple to observe and at the same time personal or your related to your personal health. So there are a lot of applications, and as you know, even big companies who are making mobile phones, watches, and so on, they are integrating what you call medical related or healthcare related items into this. So particularly in this example, I'm talking about a wristwatch. However, it's also, as you know, the importance of healthcare is also companies like Apple making their healthcare app even without a mobile, wristwatch, but just by using the mobile phone are also available. Similar things are available in Android equivalent devices as well. That is just to highlight the importance of the healthcare industry. So that's another item where the trend. More related to the homes, other buildings, and also extended places like when you put together a lot of buildings and environment together, you can either have cities or you can have what you call campuses. So they are that is a place where you go beyond a single building or a house or a household, and you connect several of them together. When you connect multiple or a city or a campus together, it's not anymore about the standalone buildings or a collection of buildings, but also it's about what's happening around them, the moving objects around them, things like the transportation related items around them or people moving around them. So all that are also going to be part of this problem now. compared to a home where it's just inside a building. But when you have multiple buildings together, so smart cities or campuses, there are more items come into picture, right? So that how do we make sure they are all together working, all these different things that are in these buildings, plus everything around it, non-buildings, even moving and non-moving and so on. How all of them can come together is what we have to consider when we consider places like smart cities and campuses. So that's another place where we do worry about the IoT is a trend now and becoming one. One other, remember I was telling from the beginning that most of these items as of now, at least in countries like ours, are towards consumers or personalized. They are not still in the institutionalized or system-wide changes. They are happening slowly, but very slowly. So here is another example where we talk about personalized retail experience. Can we apply IoT in retail? Retail industry, as you know, is a really large sector related to considering an industry. So here again, how we can provide personalized retail experience for consumers in various aspects, right? Say, as you know, like if you want to buy something online, that is one aspect of it. So if you want to buy something online, the item you bought, where it is, how it is transported from the source to the destination, which is your hand, your home, or wherever it is. So that itself is a retail experience that we can provide to the consumer. Another one is what is in this picture is a more immersive experience in a retail store. Can we provide such an experience using sensors, devices, way of identifying them, and then identifying where to find what, and so on? Can they be done with interacting with or having ways of interacting with the environment, getting information from what is surrounding us, and using them to improve the human life and the experience? So here is something that is happening related to that retail experience with an immersive idea. So that's another place where the IoT trend, the current trend is. So these are the current trends. Before I go to the next step, let me again check. Okay, all silent. Okay. Yeah. So let me. So these are the IoT as a trend. IoT is just to remind you, IoT is things which are connected together through internet compared to the usual internet where people want to connect with each other. Here things are connected. So the present trends in the how IoT is as a trend in the current setup is that these devices, these components, they mostly are communicating not just with each other but also with people, and there is a lot of people involvement at present in all these IoT. However, what something like Industry 4.0 is promoting or predicting is how these things can work on their own. Can they sense, make decisions and execute those decisions on their own without we human getting involved in it unless it is necessary? So without the human involvement, can devices work together? Just to give you an example, let's say we have a supply like a manufacturing industry or a manufacturing company. So in a manufacturing company, can just these things work together, starting from the supply of the raw material until the shipment of the product? Can all of these be done by just the things? So can the things figure out, now I need additional material, this and this and this, a bill of material, can the things look at the existing material, the production rate, and prepare a bill of material and send it to shipment or like materials manufacturer or materials provider, and certain a number of things in the provider side look at this list of the bill of material and arrange the items and arrange them to be shipped, and all these again are communicated between the two, and the items come to the manufacturing plant, and they are all automatically managed, transported, arranged. Can they be then sent into the production pipeline, and the production happens, and the packaging happens, and they are shipped out. All this what I said, can they all be done without human intervention? Can the new technologies, things like what he mentioned now, Internet of Things, and things that he didn't mention yet, artificial intelligence, machine learning, all this and all this lot of data that are available, big data, all these key terms, can they all come together to provide a seamless automated experience? But the future is, or at least the next revolution of our next industrial revolution is expected to do, right? So in fact, in my opinion, most of what is needed, most of what is needed to do all what I said, or the whole process is available, right? Most of the industrial 4.0, industry 4.0 or zero's requirements are available. What is missing are the integration, which is not that easy to do. It's very easy for us as human to interact with human. We can make mistakes, we can do trial and error, we can correct, we have a lot of other ways of understanding each other, not just the verbal communication. And therefore, it's sort of easier for us to communicate with each other. We also, over time, figured out, we are working with computers for a reasonable amount of time now. And therefore, over the last 50 years or plus, we figured out how to communicate with computers to a reasonable extent up to now. However, if things had to communicate with things, just the things and things to communicate, we had to have a set protocol, and those protocols are being developed, and integrating these things with one another is not completely transparent, or it's not completely easier to do as well. So that's where the industry 4.0 coming in and trying to see whether this integration is possible. Why I'm explaining about this is because the new trends in IoT are towards making this possible. And making this possible, meaning we are going to, the human are expected to have a better living standard, not just as a consumer, not just as a human, but also as workers, as also as those who are running the industries and so on, right? So running the industries and businesses. Right, so that's basically what the future is looking at. So before I go and discuss about the new trends and how the internet is or IoT, these new trends and new trends in IoT will achieve or trying to achieve this, I'll take a stop and spend a little time talk about a few projects that we are doing or we did in the recent past, in the last 5 years, let's say, related to Internet of Things. But I call them as research. In fact, like not all of them are research projects. Some are research projects and some are just engineering applications or application project where we build a system, an engineering system that obviously helps us in certain ways in collecting data and therefore doing some research in the future as well. I'll just spend some time talk about the projects that we did before I go into the last topic. Please feel free to put your questions if you have any in the Q&A section. So these projects, anyone interested, you can go and find them at this URL link or URL projects.cepdnacelk. CE for computer engineering, PDN is the university, ACL. Right, so that's where all these projects are listed. I'll just take a few examples. So I'll start the list of projects with some simple engineering applications, things that are mostly out there. However, we find situations where customized products are not available, and then I'll also go into after looking at this engineering projects products, I'll go into some research oriented projects that we did in the research master as well, MSc PhD projects there. So here is something that we will build little sometimes back, and also we started using the infrastructure that we built for this during. So this was built pre-COVID. So what it does is it is similar to the smart watches that we all have, but the difference is this is just a customized watch just to observe vitals, human vitals, and this was built as you can see for a hospital ward. The idea is all these devices, they are obviously things, they are connected together to like a centralized system with a dashboard. And this centralized system can, so this is a wearable device, so everyone can wear one, the patients particularly in a ward. And that can be used, and the dashboard that is built can be connected or is connected to this device or these devices. And we can look at the human vitals using the dashboard. In fact, the extension of this dashboard that we built, we also started using it in the university hospital and also the Candy hospital with the during COVID, when we don't want to get exposed to the patients all the time by not with this particular watch, but the dashboard and connecting them with the existing devices that they have, the vital observing device, whatever the devices they have at the hospital. So that is one simple project where we can put together all these things to or connect them to a like internet and make them communicate. Or actually here there's no much communication as such. It's just gathering data. So that's just a simple project we did, and there are other projects we are doing which are in the same line, but also has cross disciplinary aspects. For instance, when I explain or list down the 12 top disruptive technologies, one of the things is about automation, other one related to robotics and so on. So those aspects include including Internet of Things, because each one of these devices are also connected to the internet. So this swarm robotics project that we are doing is one of the aspects is the IoT aspects, and there are a lot of other aspects in it. The one we are seeing here are the second generation robots we have. We have two types of second generation robots. We are recently now we are building the third generation. So this we are using it for a lot of different projects, starting from application of AI and agent-based systems, obviously, and also IoT. And recently we are also using this system for what is known as this mixed reality, where we can on the same platform, whether on the same system, whether we can merge the real virtual and the physical or the real the both realities together. So what you see on this application or the dashboard are devices. Some are virtual and some are physical. So the physical ones are here on the top of the picture, and they interact with each other seamlessly. There are a number of applications for a project of this nature. Mixed reality is used in particularly places like training robots and training things like search and rescue missions and various other places. So, so basically, this is what like things that you can't do in the physical world all the time. Let's say you want to blast a bomb, you can't always do it on a physical setup and testing. However, that can be done in the virtual reality, and the mixed reality brings both together and see how we can interact with each other and train systems and so on. So that's just an example. So we again build this. One aspect of this whole system is internet, the things that are connected to the internet, particularly for collecting data. And also, obviously, this is a swarm, meaning the robots are going to communicate with each other, not by using internet, because that is the theory behind it, but IoT comes into picture in another way, like for testing and verification and so on. So the project link is here, peraswarm.c/swarm. So the project website also has a link to this welcome, like the one I mentioned a little while ago here. Sorry, here. It takes you to there. So those who are interested can have a look at that as well. So those are just two examples from the application side which we are building. And in fact, like the second application, we are also collecting a lot of data and then doing research on various aspects. Even things like this mixed reality is still a research topic, where there are a lot of problems and how the virtual and the physical realities can come together. There are still a number of problems to be solved. So those are research problems, but what you are seeing here is just like a robots and application only. We also have been working on various other projects, particularly research oriented. Here is one. This is a publication based on one of the projects related to how these devices. So in fact, like this particular project is not directly as a project related to a lot of things are connected together. However, the application of this project, where the devices that you are wearing, can you use them to recognize your emotion, right? So whether computers can recognize human emotion, that is the idea. So how do they recognize? There are various research done in this area. Things like you can, by looking at a person's face, video, and so on, you can recognize. Here what we are using is some sensors. In fact, by using EEG. So this wearable device, where we can use this device to recognize human emotion. So computers understanding human emotion is useful for various applications. In fact, like when we started this project, we just wanted to use it for a computer game actually. So the idea is whether the computer game can behave differently depends on the human emotion, the person who is playing the game. If somebody is sad, we should not, the game should be in a way. So in fact, like this, the game we setup is a very simple, like a first person shooter game. Can you make the game easier if somebody is sad or somebody is frustrated? Can you make it challenging if the person is energetic and wanted drive and so on? So can we, by looking at the emotion of the person, can we change? So that is where we actually started. But then by doing the project, by using these sensors, we realized that we were able to actually, not just realize, we were able to improve the performance, or how good we can, how accurately we can recognize human emotion using these sensors. And then the publication is related to that. However, the project is continuing and we are looking at various applications and how several of these devices put together. Let's say in a classroom, we have just an application. In a classroom, people wearing these devices, let's say just a watch. They are wearing it, but if the teacher knows the collective emotion of the class, can the teacher change the way how we interact? Even a presentation like this, I have no idea how each one of you are feeling. Whether I should spend more time on this particular topic or should I go to the next one? How do I decide? If I have some information about the emotion and state you are in, as a group, as a collection, can I get them collected by having this Internet of Things, which you are wearing? Will that be useful for me as a presenter? So just to give you an example, so you can think of hundreds of different applications where it's useful. So that's another project that we did related to IoT. like I said, it's not immediately an application, it's a research project. However, we see a lot of different applications and we are working on some of them. I hope I will be able to share them in the future. In fact, like the ongoing projects of this nature are also in the same website I mentioned earlier. They all have public access. You can go and have a look at it. The website has project description and also has some codes, things like this. So on robotics project, we have also shared them public, so you can start from somewhere and build further as well. Another project that we were doing recently and I wanted to highlight is related to actually multiple projects we are working on agriculture. So here is one related to precision agriculture. Precision agriculture, as you might know, this is a project we did recently with Queensland University of Technology, a PhD project. So we are having a number of drones, and these drones, whether we can map and then target and do what you call agriculture related things like finding weeds or weed deciding or like even other ideas, things like whether pumping or like even watering and various other aspects. Can they be done by collecting this information by having these connected devices? These devices are obviously flying objects in this example. And we looked at various aspects of how the flying objects, the drones or unmanned aerial vehicles, they can be used to do this. So this is another project that we are working on. And there are various other aspects, but one of the aspects of a project like this is how the Internet of Things come into picture. So that side of it. So another one we built recently is for our agriculture, a unit in the agriculture faculty, which is known as the Agricultural Biotechnology Center. So the project we did this greenhouse automation system where they have a greenhouse where we can do various aspects, things like collecting environmental data. And also we can control things like watering, as you can see from the pictures. And that's the complete control center that we have. And also obviously the sensors are in the area and also actuators and other aspects. So this is something we build and we are collecting data from this and we'll be using it for various other research projects as well. So that's one. And we are also working on similar aspects of other projects where the Internet of Things are involved related to agriculture. Another area where we are working on related to Internet of Things, although we have not built those devices, but we are using them, is this related to mobile genomics, and particularly these devices which are coming from this company called Oxford Nanopore or in T for short. So they have built these devices which are actually devices that are connected or can be connected to the internet or to a network. So using these devices, we can do things like DNA, RNA sequencing. And we have done some projects around this, particularly to make these devices as portable as possible. So these devices by themselves generate a sequence of signals, and they are converted obviously into a digital form and saved. And the rest of the sequencing and various other aspects, say for instance, if you have a sample, blood sample, let's say, and whether you can go to the field and take the blood sample and identify whether you have a particular virus in the blood sample, right? So if you want to figure such things out, this device itself is not enough because the device is not doing the processing. It's only collecting the data or doing this like the basic sequencing and giving you the signals. So then we build, in fact, like next slide, we build a mobile application that it's not very user friendly as you can see. However, it's published, but the mobile device, or sorry, the mobile application, it connects to this thing. What it does is it does the processing, and the application is public. You can go and have a look at it. And the application, this is also published in Nature's Communications Biology journal, actually some times back. And we are continuing on this project and various other aspects of the same project. We are working on things like how these signals can be used to, or how we can make it faster, and various aspects. So like I told you here, we are not really using or building IoT devices ourselves, but we are using existing devices, but we are writing applications or doing some research based on those data, so that you can use them to or make use of the data, or improve the experience of the data or information better. That's which I think that, yeah, so that's the last application. Yeah. So that's those are the examples I have from the research and the engineering type of project. Those are just examples. Basically, we are working on areas like wherever possible healthcare, as you noticed, next generation genomics type projects. We are working a lot on agriculture. There are the various other agriculture related projects as well, as which I have not highlighted. Small number of projects. These are just examples. So these various projects are related to in one way or the other have some connection to internet, because they are connected devices, and we make use of the Internet of Things ideas to at least to collect data, but also to do various other things, depends on the project. So if it's the smart agriculture project, we are also using it for controlling. And if it's the genomics project, we are using the data for decision making, and also like even treatment and so on. In fact, like we are not yet there, but we in fact are working with research, a medical research institute in Australia, and they do take it to the next level, although we have not done it here locally. So that's those are just examples of how the type of projects we are doing here related to IoT have become mainstream and also part of the applications that we do. So that's the third topic I wanted to highlight before I go into the last topic, which is about the emerging trends and how we can take this forward, and what are the new things that we can do. Do we have any questions? I don't see it. Right, so seems like no questions. So let me go into the last topic for today, which is in fact like related to what I the main theme, which is like the present trend and how we can take it forward. How all these things are put together and coming together. I mentioned this a bit earlier as well. A theme like the next industrial revolution, or the present, the current industrial revolution that's happening. How Internet of Things and all the other technologies that we can think of, or that are buzzwords, keywords these days, how they are all coming together is what we are going to discuss last, or the next item. So I'm going to spend some time going through the different technologies and how they are connected to, or how they can be connected to the IoT, connected to IoT, and therefore can be made a trend. Right, so that's the idea. And the IoT trends that we are discussing here are technology related. In fact, like if you go and look at IoT trends, there are other social and economical aspects of IoT trends. We are not discussing those here. We are just looking at the technology side of it only. Just to keep the disclaimer clear and our scope clear. Right. So one of the trends with or without IoT, as you know, is cloud computing. So cloud computing is something that is one way or the other connected to things like big data, right? So where one of the places where big data is generated is IoT. So Internet of Things are going to generate a lot of data. So therefore, in one way or the other, cloud computing and Internet of Things are going to be connected. They are connected. They are getting connected. So why? Because there are a lot of data, and all this data has to be kept somewhere. And cloud computing or cloud storage is considered a viable option. However, when you want to keep data in a cloud, then there are both positive and negative pros and cons related to this, and there are a lot of new ideas or projects, research that can be done in this area. For instance, now if you want to send a lot of data across to a cloud and store it in a cloud, then obviously the things that are sending those data has to be connected, and therefore they are Internet of Things first. And then these even what I mean is, even if those things are not Internet of Things by nature for their own application, but if you want to keep the data in the cloud, then these things are going to become a part of the internet, because that's how you are going to communicate and send things across to a cloud. So, however, even Internet of Things can also use the cloud storage to keep. The challenges are when you do the transmission or sending this data across, how can you make sure they are securely transferred or sent across? And also, obviously, when you are storing them, how do you make sure the security and the privacy of the data are say protected? How do you make those sure? There are a large number of various projects that are research that can be done in that aspect. So one aspect where cloud computing comes in touch with IoT, that's a trend, and a lot of work is done in that area. And one other aspect related to, I actually mentioned a bit about this as well already, is related to cloud computing, is how do we do things like protecting data. In fact, it can be sometimes kind of, so I wanted to spend a little more time, or I want you to think about it a little more about IoT or these things and the data, right? So usually these things are let's say you are buying let's say a weighing machine, a machine to measure your weight. So obviously you are not going to program it, or you are not going to install an application to it. It's all pre-installed and come. Now you're going to connect it to the internet. So how do you make sure, or how the manufacturer of this device or the weighing machine, which is an IoT, how they make sure the data that it's going to collect, private data, obviously, your weight, can be protected. If you are going to send it across to the cloud, how it can be protected? As you might know, most of these devices are consumer devices, and they are towards the end of the on the consumer side with very little protection. The reason being, they are not well designed, versatile products in terms of security or privacy of data. They are mostly focused on their accuracy, how they work, and so on. So even we don't have to go to that extent. We don't have to go to like an example like a weighing machine. We can just look at our home router, which is a device that is supposed to connect the computers together, a Wi-Fi router. As you all of you are aware, a device like a router, again, we don't install applications to it. It's all pre-installed and coming. And particularly, it comes with something like a default password. And unless you change the password, it becomes a vulnerable point. The others can come in and change your password or have access to your devices, have access to your data, have access to your browsing history and whatnot. Right. So these are examples of situations where I just took this home route example for you to understand how the Internet of Things, when they are connected to the internet, and when you want to have them connected and have access to cloud and vice versa, like both ways, you send data to the cloud and you have something that you can take some computation that is done in the cloud and it brought back to the end device and presented or shown. For example, whether we can compare a few people's weight and say whether you are above average or below average in the weighing machine example. If for that to be done, obviously you have to have multiple devices connected and data collected and an average taken. And then the average sent back to your personal device. So I'm just coming up with the example. So such a situation, how do you protect data? How do you make sure that they are not someone malicious come and get hold of such data in various such applications? So that is a problem, and therefore there are a lot of research work that can be done in that aspect, start on the data protection side and various other aspects related to it in terms of connecting IoT and cloud. Maybe I'll go to the next one and I have just one more thing to say there. So the next one is, as of now, as you might know, the term edge computing is becoming really popular. The reason being, the edge devices, meaning these small IoT things, are becoming powerful enough to do computation there itself. We don't, so which has both positives and negatives. So if you just go back and think about what I said a little while ago, cloud computing is about sending the data to the cloud and do processing there. Obviously, storage is another situation where you use the cloud, but computing also is done in the cloud. Here we are talking about the other side where the data is processed on the edge device itself. The good side of it is obviously these devices, if they process data, they are to some extent what you call safe, or the privacy can be maintained as long as you are going to process at the end device, the edge device itself. However, there are again challenges. How much of this processing can be done there? And when you want to do such processing, don't you have to communicate with, don't you need any additional information that can be only done by aggregating data from various devices? So there should be communication happening on both, like the opposite side, where an aggregation of data from multiple devices go into a central place, and the aggregated answers might have to be pushed back to individual edge computers for doing so. That's a challenge, and there are a number of different models proposed, frameworks proposed, and a lot of work done on the edge computing aspects related to data processing. So talking about this edge, cloud, all these aspects, one what I discussed up to now is about how these can be, the data we have there, the data we collected, the data we are processing, all these, how they can be sent across, manipulated. At the same time, these IoT can also be used to observe things like vulnerabilities, things like malicious intentions, things like what we call attacks. So in fact, like these edge devices or this IoT can also be used to identify attacks. How? By looking at trends, by looking at what's happening. Let's say two similar type of environments are there in my office here and another office in the next building. They both are similar usually, but at one point my office data is behaving differently, or my office devices are behaving differently. Can these anomalies be identified? So such things are possible when you have these IoTs connected. It's not just about protecting data, but also understanding what's happening in the environment or what's happening to these devices by someone malicious. So that is another aspect which is outside from protecting the data the environment is like these devices are collecting. So that's also possible in this aspect. So there is sort of a reasonable amount of research done in that aspect as well. One other is machine learning. So when it comes to machine learning is another trend, as you know, and it is again coming together or hand in hand with Internet of Things. How the two can be combined and brought in. As you there are so if you are just talking about machine learning and data collected using IoT are going to be used for the machine learning, we again have to worry about the data security there, right? And how they are done. There are a number of things that are again coming into picture. Things like the blockchain and various other data security related measures. Distributed measures that are or distributed technologies that are used to protect data and so on, they can also be used in those aspects. And there are a lot of work done on using machine learning to automate these processes as well. And with IoT and with the data and machine learning, it's also possible to make decisions. I mentioned a bit about it earlier. Industry 4.0 is taking the automation to that level using Internet of Things, all these sensors, and also decision making. Can we make decisions by analyzing the data and using artificial intelligence to make decisions? The factory example or the manufacturing plant example I gave, where an industry 4.0 manufacturing environment will be completely of that nature. So we are starting from the incoming raw material until the shipment of the product. The whole process can an AI take care of, right? So how it can be done? Obviously by looking at the data and analyzing them properly and making decisions based on those, right? So that's again another place where IoT come into picture and can be used, and also it's a trend. So in fact, like I mentioned these numbers at the very beginning as well. So because of the growth of Internet of Things, as of now, there are about 30,000 total devices. That's the estimate, including the sensors and actuators and so on, which are connected to like gateways altogether. But half of these numbers, if we ignore the small like sensors and so on, those are numbers again estimated or counted like based on research calculated. So these are the number of devices that are out there. 30 billion is the number that is estimated. It used to be like this estimate was have in 2021 as well. And like I told you, due to various limitations and problems around the world, starting from war, chip issues, transportation, logistic issues, all that. Even the present estimate is saying by the end of 2022, the same numbers it's going to be the same. So there's no big, the expected growth has come down a bit in the last 2+ years. So how the machine learning and AI I mentioned earlier, so they can come together to use the data that is collected across all of these. But so that's another trend that I already highlighted with the previous one as well. And the next one is can these data be used for this idea like maintenance, or what is known as predictive maintenance boost? Right. So the idea is, can these devices, the systems, if you think of like the example I gave earlier is in a manufacturing plant, can the whole process be automated? Taking it to the next level, can we make the same system to repair itself if there's a problem in the manufacturing plant itself? Like it's not completely possible. unless you have enough redundancy in the system. If the system itself goes down, how can the system itself repair itself? That is the issue. But then if you have enough redundancy, it's possible to do self maintenance, right? So here we are talking about whether we can predict maintenance. So meaning, let's say a part of a manufacturing plant, part of the plant is getting going to fail. Can it be predicted by using data, by using AI, by using machine learning? Can we predict the part going to fail, the part getting aged, and so on? Can they be replaced? Obviously, when you say replaced, they are going to be ordered, shipped, replaced. At least most of this process, can it be automated? So that's the next level. So it's like self-repair. The previous case was like manufacturing example. Now the manufacturing plant, can it repair itself? Obviously not by like regenerating, but by bringing or understanding that there's a repair required in the future, or predicting for a repair, for a maintenance, and doing the maintenance by itself by analyzing what is required for the maintenance, bring those items in and so on. So that's another area, predictive maintenance. A reasonable amount of research work is done there. Here is based on this, there are services that are coming in, things like home care service. Like someone come and make your things like this, home automation, factory automation, any one of these, or smart cities, all these places, wherever there is automation happening and IoT communicating with each other using AI, understanding what's happening. Can this be used just for running, but people are doing normally, or can it also be used to maintain the IoT themselves, the devices themselves? Right? So, for instance, if you take like a synonym or like a parallel, people in a factory, whether the people in the factory are going to do manufacturing, at the same time people get wear and tear, so they get tired. Can they go and sleep, wake up? If they get sick, can they go to doctor and come back? So all these are in the human setup. Can this whole thing be replicated, done on a complete things setup, where the things not only work but also repair themselves, or take initiative for repairing themselves? So that's the next step. That there is a reasonable amount of work, research done on that aspect as well. Taking it forward, actually I mentioned a bit about security earlier. So when you, when I was talking about security, there I was just talking about what you call sending data and cloud and in the edge device. But even between devices, which we didn't discuss that much earlier, IoT is not just there to connect and communicate with a server and an edge device or edge node, but also to communicate with each other. So when they want to communicate with each other, how do we make sure they are trusted, whether they are trustworthy, whether there are no malicious devices, whether can the devices become malicious, or can someone come and put a malicious device within a trusted network? And such problems are also being addressed in research, and things like blockchain again coming into rescue and helping us solve those problems. So one of the applications there in IoT with blockchain is security. And also I mentioned some of this earlier as well in another aspect from a cloud perspective is regarding the how do you maintain the data at the backend and so on using blockchain. So we are looking at it from a blockchain perspective, so I'm not spending a lot of time there. One other, so with all these new ideas coming in and things getting automated, AI coming in to help to make the or help us make decision, or help the things to make decision. A lot of new things are happening in the service, or things are becoming services, starting from software, systems, devices. Can they all become services? So where the users can just go and subscribe to this, and the rest are taken care of by systems and provided as services to us, right? So things like without human intervention, can I just order as a human? Let's say I want a shirt and I want to order a shirt. I want a shirt and I have a particular measurement. I put that to the system and or somewhere as I like I just ask for a shirt and can the shirt be delivered to me, starting from everything, right? So from the manufacturing, from stitching, whatever, right? So shipping, finding material, all that whole process, the whole cycle. Can this be provided as a service without a lot of human intervention? So that is where like Industry 4.0 is trying to take us. This example I gave is small, but it can be for anything like building a car or building an aeroplane for that one. Right. So those are also happening, and these are the new things that we are looking forward and working towards, thinking of a revolution and a disruption that changes how the world will be in the future. Right. So that's basically it. So that's this. In summary, I was talking to you all about what's IoT. And IoT, Internet of Things, over the last 20 years or less, have become a trend in various aspects, starting from consumer side to factories, businesses, logistics, transportation, also in various places. And I spent a little time telling you about the research and engineering projects that we are doing in Peradeniya related to this. And towards the end, I also have shown you how the new trends, the current IoT trends, combine the other disruptive technologies like AI, ML, and things like blockchain, cloud computing, how all of them are coming together and will make or is expected to make a change in the way how we all operate, not just as consumers, humans, but also as businesses, healthcare industry, all these different aspects, and any other automation, any other sector, how we all can, how these things are changing the way how we operate, is what we have seen towards the end. So that's basically what I have, and I'm happy to answer a few questions if you have. And thank you.
Thank you very much, sir, for your informative presentation. So now the session is open for your questions. So if you have questions, you may type the questions into the Q&A box, and we can bring them up to the professor. If you have any questions, you can use this time.
So while you are typing questions, so if you have, if you are interested in working with us on any of these projects or anything else, you can reach out to me and I can join you to whoever is working on those projects. Yeah.
So I think we have some questions coming up. So there's one question. Sir, are there any components or applications that are specifically made to create or simulate an IoT system?
Yeah, so the question is components application. Actually, there are applications that are built just to simulate IoT system. Even in Sri Lanka, there are industry companies who are making such simulators. Even like the example I gave you about the robotics example, we also have a simulator build, which is to simulate the IoT system, so that robotic system in that example. So there are a large number of such system simulators. There are, you can find a number of them in the web as well. However, the simulators alone are not good enough, because here we are talking about things. So not everything that is like environmental related, outside related can be simulated. So even if they are simulated, they are different from the real world. So therefore, there is it's not just like a software system. Therefore, simulators are there, yes. Even we have, we are using it for certain tests. However, it's not simulators alone can't solve or simulators alone can't do what is required. Okay, so that's so the answer to the question is yes, there are simulators, and even we have some. You can find them in the project site. Yeah. The next question, maybe we can go on. Yeah.
There is another question. Yes, Professor, are there any researches going on for incorporating mixed reality for distance learning?
Yeah, so we are doing one project. It's still at an early stage on not exactly as mixed reality, but something like not IoT project though. That is why it's not included as well. Related to distance learning. So can we use things like right now we all are behind the screen, and also this is a webinar where we can't see you all, but if we can see, can the system tell me that, let's say the Zoom meeting tell me how many of you are bored, how many of you are not, and so on. So such a system we are building, but it's not real. Yeah, it is to some extent some reality because they are physical, and also the machines coming in or the computer vision coming in and telling how people feel about each other. That sort of a thing is what we are doing. And there are a number of not really projects, but we have during COVID, we have set up a number of labs like hardware labs that can be done through mixed reality. So that we have set up and students are using them now as well. Say for instance, if you want to do programming on a programmable logic controller, PLC, then we have set up a system so you can be at home and you can program through a web interface or some other interface through a computer, and the devices can react to your commands and your interaction with the devices. So yeah, so there are a few projects we can. If you are interested, yeah, please let me know. I can connect you with the people who are interested, who are working on those.
There's one important question. Are there any reasons or what kind of programming languages should be used when it comes to simulating IoT applications?
Simulating, is it?
Yes.
Okay. So simulating the application that are built, what we have are using mostly scripting languages. Say one we have where we are using things like JavaScript and so on, and that is for like the simulating part of it. And for programming the IoT side of the devices, we are mostly using C++ type languages.
There's another question, and he asked that is it necessary to have cloud component in every IoT system?
No. So cloud is a new technology, as you know. It is not necessary to have cloud in all such situation, but cloud is becoming useful when the IoT becomes large and scalable. So cloud will help the scalability when you have large number of devices connected. So, but however, it's not like a mandatory requirement.
So there's another one question. Someone is asking how to join this project that you mentioned.
Yeah, you can just, my email address is here in the screen. So you can put me an email and I can let you know, depends on what your interest is, which group to join. So we have a number of groups working on these projects. I can connect you to the right people. Yeah. I also see there are some other comments related to WhatsApp, how to communicate and so on. We'll start with an email and then we'll decide how to communicate. Yeah. All this communication will start with email. Yeah.
Sounds nice. So there's another question. I think we are getting many questions right now. There's one more question. Is it possible to use IoT for water management in irrigation systems with farmers?
Yes.
So how expensive would
in fact, there are companies in Sri Lanka, startups and so on. Those are working on things like water management and using IoT. yeah, so that's the short answer. The answer is yes. How expensive? I don't have a clear idea of the price, but however, it's not going to be that expensive actually, because there are at least 3-4 companies in Sri Lanka who are doing it for reasonably middle level industries or farmers. However, the low end there's not many. If you are interested, I can link with those who are. Yeah, you can just.
There's another follow-up question to the same. Are there any limitations to it?
Related to related irrigation, right?
Yes.
So limitation in the sense, yeah. So as you have identified, cost is a factor. That is what I see as limitation. Otherwise, so things like irrigation or smart irrigation is how irrigation is irrigation, and also other related what do you call agriculture related factors are happening in other countries. So yeah, I don't see any other limitation other than the cost for now. Yeah.
And there's one interesting question. If we use AI technology for IoT in future, will it be good for humans? I think he's asking for your opinion.
Yeah. Yeah. So I don't know whether you noticed. I put this image for a specific reason. We want to be in control, right? So yeah. So this one. So whether we want to let AI to make decisions for us. So this particular human saying, no, I want to make my own decisions. So yeah, so this is the thing, right? So it's like a very open-ended question. Whether we can keep the AI to do only what you want to do and so on. So that is where we want to be, but yeah, we don't want to go beyond. Yeah, we don't want to make, even now, if you carefully think about it, we are to a reasonable extent following what our devices are saying. For instance, now I came to this webinar by my calendar telling me at 1:30 to join this, right? So not by my intention, but yeah, so I put that in the calendar earlier. Yes, it is in one way. Yeah, so I'm just following the calendar, right? So that is a starting place to all this. As long as it's convenience, it's good. But if you go beyond, then there's a problem. Yeah. So we all researchers who are working on AI are trying to be within that limit. Yeah.
There's another question. What are the good resources to learn more about blockchain and IoT technology?
Blockchain and okay, deep learning. Resources, I think there are good courses you can follow now, not like early days. These days you have decent courses from good resources. You can follow it from some open MOOC type of places like Coursera type courses are good. I think that is the best place. Yeah. If you are like a reading person, then you can start a book, like read a book. There are plenty of good books. Yeah.
There's another question. What kind of job opportunities does IoT open for us?
So Sri Lanka, like I mentioned, even in the irrigation agriculture sector, there are 4 or 5 companies now working on IoT related, and more are happening. And industry 4.0, even the government is trying to push, the government agencies are trying to push these days. So the things like Internet of Things, not just programming, but more of systems where devices and computer programming connected to each other become complete system. There are like large number of opportunities expected to grow in Sri Lanka as well. So like I said, even agriculture, there are about 4 companies now who are doing mainstream automation of agriculture. But there are plenty of opportunities actually. Even if you take places like factories and all these other places, there are a lot of things that can be automated. They are not doing it. At least medium scale industries are not doing it here because they are way too expensive to import such automation system. However, some of them we also can do. In fact, like I wanted to include one and forgot. We are working with the factory. We are doing some automation work where the IoT devices are put to do some small automation. So they are existing machines, we can interface with them, get data, make some decisions instead of people making decisions, such things. So there's enough and more opportunities that are coming up, even for local and also foreign opportunities. We can export such things. So there are more coming. So if you are a student and planning on, if you are interested in such things, either you can join a company or you can even start your own. There are enough opportunities. Yeah.
There's another question. Are there any possibilities to build smart classrooms with IoT devices and like to facilitate a personalized learning? So what are the possibilities in that area?
Yeah, so there are a reasonable amount of work done on education related to IoT. I didn't discuss them, but yeah, it's possible, yes.
There's another question. What's the procedure for creating cryptocurrency using blockchain?
Yeah, I will not go into those details here. In fact, like I'm also not an expert in blockchain and cryptocurrency. But what I know is the blockchain is what I was talking about when I want to protect data. It is just to make sure we understand, like, so when you do communication, both parties understand each other or trust each other. That's the idea. More about it, you have to study further. Yeah.
There's one more question. So how important IoT for businesses?
Yeah, very important. Like I mentioned, the IoT trend now it's going from consumer to businesses and factories and so on, healthcare and big sectors, industrial sectors, and therefore it's very important. So that is where the new trend is. Yeah.
Okay, if you have any more questions, you can ask now. I myself have some questions to you, sir. So when it comes to cloud computing, so we know there are some cloud service platforms like AWS, Azure, like that. So what are the mostly widely used services for IoT? I mean, are there anything for free or something like that?
Free, yeah. Okay, so there are like for learning we have, you might already know. However, for production state, we don't. So for learning, there are, so even for students, you can, when cloud providers are providing solution for students, the larger cloud providers, but if you want to use it for production, we don't yet.
There's another question. Can we do a voting system using blockchain?
Yeah, so there are voting systems that are built using blockchain. Yes. Looks like we are done.
Do you have any more questions? Students, do you have any questions?
Yeah, if not, we can wind up. My calendar is telling me to join the next.
Okay, I think, yeah. So I think I did the time limitation as well. We have to wrap up the session now. So dear participants, finally, we have come to the end of the session 3 of the pre-conference today. So on behalf of the Institute of Technology, Institute of Moratuwa, I would like to extend my most sincere gratitude to Professor Roshan Ragel for accepting our invitation and for being here with us today to deliver an informative and interesting presentation. So your thoughts have truly inspired us. So, and also I take this opportunity to thank pre-conference organizing committee, IRC ITUM 2022, for coordinating this event and make it a very successful one. So I finally want to thank and I really appreciate all the participants for their valuable presence here today. So I hope this presentation was an eye-opener for everyone who like to explore and conduct research in the domain of Internet of Things. So thank you once again. I think we can wrap up the session now, and thank you once again and have a nice day.
Thank you, everyone. Thank you. See you.